Okay, so we are going to be talking about the Bison plugin the Bison plugin for Grasshopper in Rhino. You can get it off of Food for Rhino. It's an easy download. You just have to log in to Rhino. What's nice on their page is that it has the actual plugin, but it also has the reference as well as example definitions. So if what I say and do doesn't make sense or doesn't work with your model, you can always look at their reference or their definitions and see if you can figure out your problem. As well as obviously Food for Rhino has comments and reviews and everything that you can try and troubleshoot in. So after you have downloaded it and you go to your Rhino page, you can go into Grasshopper, and you just have to go into File, Special Folders, Components folder. Mine is already in there, but when you download it off of Food for Rhino, it'll be in a zipped file, and you just have to open the zipped file and then copy and paste it into this Libraries folder. Mine showed up immediately. I didn't have to restart anything, but you may have to restart your Rhino to get it to open. So, yeah. The first thing that you either need to do if you want to edit a mesh is to get a topographic mesh. This plugin works mostly with meshes. You can make your own mesh off Bison, and I will show you how to do that later. But a lot of this is very easily displayed on a topographic map. So one of the places you can go is that you can go to the USGS website and you can get topographic maps. They're quite detailed. Oh, I'm probably zoomed in too far. Anyway, they're quite detailed, and they include all waterways and everything. The other place is that I got mine off of Terrain2STL because you can choose the exact size of the rectangle that you want. This is the box I chose, but you could change the ratio, whereas the USGS website doesn't let you change the ratio. All you have to do is place the box where you want it. I chose the Ohio River Valley and Cincinnati. And then you can just press Generate Model and then Download, and it will open as a zipped file. And then you can open it, and it'll be an STL file that you can import into Rhino, which you just import, and you can see it's right there. It'll import as a mesh already. The way mine imported was it had kind of a base layer, so I took that off, but you could leave that on. Okay, so getting into the Grasshopper now. This is what the Bison layout looks like. So the first thing we're going to do is define our mesh. So the most simple thing that this program does is remeshing, which you can do in Rhino. It does take a lot longer for Rhino to remesh stuff. It has to, pick out all the points and everything. This remeshes really easily. So mine looks like it's a square mesh, so I'm just going to remesh square. So you just got to put your mesh in, and then grid, however big you want it to be. And original is also a slider. You don't have to put the original in. You can just put, the grid, because then we can, that's not what I wanted. We can just bake it. Let's grab it. So you can see it's a lot more simple, and that was super duper fast. Rhino didn't have to do any thinking. And you can choose exactly how big you want it to be. 5 would make it even more simple. Or less. I'm silly. It's the distance between. So the smaller the number, the less simple it is. Excuse what I said earlier. So you can see it just simplifies stuff. If you need to simplify a mesh, if you already have this plugin plugged in, it's super easy to remesh. It takes a lot less time than Rhino does to do it, but it is something that Rhino can do. The original doesn't really change much. you can see that it says, if you go to toggle, false, we'll do that. Whoops, that was the original. Again, I did not mean to do that. So you can see it's the same, and then if you switch it to true, it changes just a little bit because of the Boolean. So you can do that or you don't have to. It doesn't really make that big of a difference, but you can see in this one, it's a lot more complex than it was when it was at Boolean false. It has a lot, like the center points move. So it just depends on how complicated you want your mesh to be in the end, but that is how you remesh stuff. I'm not going to need that again. You can also, so they have random remesh. You can see that that's just the mesh and, oops, and the grid. And that one will mesh it not, so the last one was in a rectangular pattern, and this one is, as it says, random. It just connects points. It almost looks like string art. But it gets a lot more of the curves, and it's a lot less geometric. You can also do triangular remesh, which is almost exactly the same as the first one, so I won't do it again. It just is a triangular. As you can see by the icon up here, it's not rectangular, it's triangular. So like I said, like I was saying earlier, you can, make your own mesh from curves or even points that you create. So let me just create these real fast. And that is called triangulate mesh. So you just want to get some curves, and we will multiple curves. It's the same thing for points, and then you just load it into your mesh. Let's look at it in perspective. So it creates a mesh, and you can move these up and down, like if I wanted a hole in the middle. Again, like I said, Rhino can do it. Again, it's not quite as fast in Rhino, just because if you move a curve in Rhino, whatever you did to create that surface doesn't follow. Whereas in Grasshopper, before you bake it, everything follows. Like I can make it really deep. And obviously, if you have more than 3 curves like I do right here, it will be a lot more complicated. And you'll see later that even if you have a flat mesh, you can edit it there as well. But you can create your own topography. But if you're looking at a specific topography and you need to grade the land or something, this is a really nice tool to edit actual existing topography that you are going to change for whatever project you're working on. So that is how the triangulate mesh works. So we'll get into the mesh edits. So we'll start with the mesh point. So you got to put your mesh in, your slope, pull our mesh out, and then you need a point. So you can do this for now. You can do this with 1 point or multiple points. I'll just show you with the 1. So you can see how high it is right now. Hello? There we go. So when it's high up, it's flat because you're pulling it off of that mesh and it's not touching anything. But as you drop the curve, or you can pull the curve in any other direction and get, like, if I were to do this, it still stays within the entire boundary, but you see this part is going to be entirely, you're not going to see it at all. Let's bake that so you can see it. Is that the new one? Yeah. So it has flattened out everything except for these points that you can see above where I put it. But yeah, so it lays kind of on it. You can also go underneath it. So this is kind of a really fast and easy way to just pick and choose what parts you want to see. Like you can see here's the Ohio River, but it kind of tapers off here. You can't see it anymore because it was underneath the curve. And you get a little bit of this mountain, but you don't get those peaks anymore. So that's just a really simple and easy way, especially if you use the 1 point. But if you set multiple points, we're just going to randomly pick some points. This one's a little bit more difficult to just logic. Oh, that's the 1 point. Because it's hard to tell what each point is going to do, but you can just play around. You can see as it pulls down and up. Each of these points are kind of a way to just edit the mesh, what you want to see versus what you don't want to see. Sometimes they don't do anything because they don't have enough control. That's the one that seemed to have control. There we go. But again, it starts off kind of flat until it intersects your mesh that you already have. Okay, those don't seem to be doing anything. I picked poor points. This is the second time I recorded it, and last time I picked way better points. But yeah, so you can just kind of, the way that I did it, you can see where it intersects. It kind of just took the general curvature. You can see it dips down here. It didn't intersect my mesh all that much, but you can use multiple points. It's a little bit more difficult than the 1 point, but if you want different points, I would recommend a different way that you will see later. So that's the mesh point. Then you also have mesh point pull, which is very similar to mesh point, as you can probably tell by the fact that the name is very similar. Right, let's set this back to 1 point. And then we'll just throw that in there. So I don't know if you can see in the red there, but that point is controlling this one single mound. So if you want multiple points, I like the mesh point pull a little bit more, just because it's a little bit easier to understand what's happening, in my opinion. You can do the multiple points with this as well. I think you can see that I don't need to bake it. Oh, okay. So we're just going to do that. And so you can see when I turn it to the side, each one of those points has its own little mound, and it's a lot easier to just adjust each one of them. And if I made the height higher, you could make more of a difference. Let me just switch those out so that it's a little bit easier to see. Okay, so obviously that's a little bit drastic, but you can make it go a lot higher or a lot lower. Also, if I were to change the width, let's put it at 10. They obviously take up a lot more. Let's just bake that for fun. It's like a spikes in the ground, but yeah, so you can still see that Ohio River base mesh, but you can really manipulate it. Obviously, this is a really extreme example of how you would use that. I probably would not have them that tall almost ever. Like here, let's see if I can make it a little bit less drastic so it's a little bit less cartoonish. But you can kind of create these little mounds that would be interesting if you were to do like an architectural project that needed you to change the topography. Obviously, you're not going to change the topography on one side of the Ohio River and on the other, but sorry about that. There we go. It's a little bit less cartoony, but or if you're just doing a theoretical model, you could start with the topography because it's a little bit less daunting and kind of edit it how you want it. But yeah, I would definitely recommend mesh point pull over mesh point for multiple curves. It makes a lot more sense. Then we have mesh curve, which we can get rid of that, which is very similar. I need to draw a curve. Let's make it a little bit fun. It's a very similar concept. It just follows the curve. Again, it starts off at the height that your curve is at, and then it just follows whatever height your curve's at. So maybe I shouldn't have made a fun. So you can see that it followed the curve. Let me draw a new curve because it going back and forth doesn't really make it all that clear. We're just going to make it really swoopy. All of these can be done using multiple or less. The other thing that makes it a little bit more evident is the slope. So you can see the slope changed a lot. And if I do this, it doesn't go underneath unless you pull it underneath, and it'll only go underneath. It only goes in one direction at a time. But I can kind of create kind of mountain range. I think this is a lot easier to see how it follows the curve. The other one was just not visual enough. So you can see it followed that curve. Obviously, if you change the slope to be less, let's actually make it a lot less. We'll half it. It makes less of a difference, less of an impact. You're trying to be subtle. Again, a lot of the things that I'm doing right now are kind of cartoony just because it makes it easier to actually tell what is happening and how this program works. But this reminds me a lot of our of the assignment E5 where we were trying to make tunnels and everything, and by putting all of those surfaces over, and it would be really easy just to push and pull the mesh through these scripts. So there's that. They also have the mesh curve pull, very similarly to the last one with the point pull. It makes a little bit of a difference. Oops, that is not what I wanted. It makes a little bit of a difference, but this one is a lot easier to edit the width. Make the width really wide just for fun. So you can see. So you can see all I did was change the width, and it is way up here because it was at what, 10? So you can see it goes, it's very different if I even do 20. So you can see it follows the curve, but whereas on the mesh curve, the curve was the apex of whatever you're doing, whereas in the mesh curve pull, you can choose the height and the width and all that. So you don't, it just follows the form of the curve, and you can actually manipulate other stuff. So while the regular curve pull and point, not curve pull, mesh curve and mesh point are useful, I find that the curve pull and the point pull are a little bit more useful for rapid prototyping. So you can see that I pulled Kentucky up a bit. So there's that one. And then the last one that I want to show you is the mesh flat. So you have the mesh and the curve and the width. Oh, I forgot. we're gonna have to draw a new curve. For this one, the curve has to be closed. So let's set our curve. Oh. Okay. Interesting. I did this earlier and it worked just fine. There we go. I could not tell you why that did not work, but it just creates kind of a terrace wherever you want to put it. So like if you were to, I don't know, design a road to your house or something, you could just have a curve to that and it would, or even if you're, in a regular project when they have to grade land to put a house on it, this would be a really easy way to just take the existing topography. You set the boundary for where it would be graded or where you would like it to be graded, and this will very easily make that happen. Here, I'll just bake that so you can see it a little bit easier with the shading. But yeah, so it flattens wherever you put that boundary, that closed curve. Okay. The other things you can do is you can take sections of your mesh. So if you take the mesh, I don't have a curve anymore. Let's just throw our curve in again. Curve. And then for this one, you just want the basic geometry as your output. So you can see, let me highlight it. So you can see the sections that it's cutting along where I put that curve. If you were a normal person, if you wanted the topographic lines, you would probably just do straight lines across. And then the linear is what a normal person would do, where you can see where the topographic lines are in a straight line instead of where I chose to put it on this curve. I don't know why it does both linear and the curve at the same time, especially if your curve were to be linear. And I'm not sure exactly why it only chooses this single one, but if you wanted a specific straight line curve, your best bet is to just draw a straight curve. Here, let me see. Let's just draw a straight curve and put it, change the curve to that. So, unselect it. So you can see in a straight line where the topographic line is. Even though it's a different curve, it's the exact same linear. And like I said, I don't know why. I don't know why that happens. But yeah, so that's a really useful tool if you want topographic sections. And you can select multiple curves. Let's choose both curves at the same time. And you can see that it will do both. So if you wanted to do like a regular, 10 feet across grid, so that you could get grid lines, that would be a really easy way to do that. So that's the section profile. They have other sections, which is the serial distribution, which is serial, kind of like what I just said, if you wanted like 10 across. This is very similar. You have the mesh, curve, interval, width, and it just shows you. So you can see it runs along the line of your curve, and the width, I don't know if you're going to be able to see this very easily, but if I made it wider, you can see those lines got wider. So you can choose along that curve how far out you want. These are just perpendicular to your curve. So it's a really nice, easy way to get those topographic lines. Just to see interval is obviously how far apart they are. If I made it bigger, they would be spaced a lot farther apart. Again, with the linear, I don't understand it, but it does the same thing here as it did in the other one. And the curve height on this one does not matter. It just projects straight down. So there's that one. And then there's also section to XY, which you only put in the linear curve, and it will give you all of this different information. But I'm not going to show you that right now. The other thing that this is good at is analysis. I'll delete those. So if you had a location like the Ohio River Valley that you wanted, you can analyze a lot of things. So this is the aspect. You just plug in whatever angle you want it at. So let me see if I can. The other one's 50. So you can watch and see when I do it, see how it changes. And if I make this, 100, how it changes again. The mesh that it puts out is the exact same mesh as it is right now. So if you wanted to duplicate it, you could, I guess. The other thing is that you do the legend, you have the colors and the tags, and you can see kind of what each one of them means. If you want that information, that's how you get that. And then concavity, you just have to put in the mesh. It kind of shows you the concavity of everything. Again, it puts out the same mesh, but here you can see what the colors mean. So yeah, if you had a landscape or a topography that you were told to design on, whether in school or in reality, if you could get the topographic information off of a online resource like I showed you at the beginning, you can analyze the topographic nature of your site and design from there. So that's the concavity. Elevation is very similar. Mesh, colors, tags. I do not know why it does one fish, two fish, red fish, blue fish when you just put in the color. It's very interesting. You can choose the min or the maximum elevation. So you can see if I put in 10, 5. I don't think that I just did that. Or you can just not have it at all. I'm not sure what number would work there. Let's see. We'll move on if I can't. I have noticed that the min and the max kind of makes it disappear. Yeah, I don't know. Okay. Oops. Yeah, so you can see, they're all in the negative, that's why. Let's just try one more time. Oh. Negative 100, not subtraction. Never mind, okay. So that's the elevation. The flow, you have to put in, mesh. You have to put in a lot of information. So here's the boundary. The curve. A lot of numbers, grid. Steps. So this is just, this is the best way for you to get a topographic map. Come on. Do what I want. Let's reduce our curve. What's wrong with it? Floating perimeter. Can't see where it is in elevation. Okay, but yeah, so that's that. You can also get roughness. Again, you just have to input the mesh and it gives you a lot of information out. So a lot of the analysis of a site. So you can see mine is, again, the one fish, two fish. I don't understand. Not all that rough because you can see it's this warm color. It's where it comes at the peaks where it's rough, which makes sense. But if you had a really rough surface, you might decide to grade it or something like that. So you can check the roughness. I think the coolest one is that you can kind of guess it'll show you shading depending on where the sun is coming from. So if you know where the sun's going to come from, so let's say it's going to hit on the opposite side, you put in the vector, get rid of our legend. I don't know if you can tell, but you can see where the shade is, where it's light pink is where it's shaded when the sun's coming at that vector, versus the light pink is where shade will hit it. So we could change our vector and have it sit right in the middle, and you can see that because it's hitting right here instead of behind this one, there is a lot more that is in the sunlight, where the light pink is a lot less. So I think that's one of the most useful analysis aspects of this program, where you can see the shading and not.